okay? So I'm taking these two functions, adding them together. With addition, though, I can drop the parentheses and just go right to combining like terms. Right, there's no distribution that I have to worry about. They're all going to have the same sign, and we're going to see how that differs later on in some of our problems. But I can just go right to combining those like terms. So what can I combine, and what would my final answer be? Good, so 3x minus x gives me 2x plus 6, right, from the 3 and the 3. So 2x plus 6, good. And when you get to your quiz on Friday, if there's a question that's similar to this, all you'd have to do is type in your final answer, right? So you don't have to worry about typing in like g plus h of x equals this. It'll just be there for you to type in that final answer, okay? Any questions about the first example? So when we're adding, we just combine like terms. Let's jump down to example 4. Now I'm taking those two functions and subtracting them, okay? So I have h minus g of x, and that's kind of the notation that you'll see for a problem like this. So I have x minus 1 minus 2x plus 3. Right. So I have to change the signs because I have to distribute this negative. So that's what we said in here. So now this becomes x minus 1. Instead of plus 2x, it'll be minus 2x. Instead of positive 3, minus 3. So we need to make sure that any subtraction problem that we see, we distribute the negative to start. Then we can go through and combine like terms. Okay. And when I combine like terms, what would my final answer be?
Wouldn't it be negative x? Wait, no, yeah, negative x minus 4.
Yeah, exactly. Okay, so I wasn't sure if you were asking a question or you're telling me the answer. So yes, so it'd be x minus 2x gives me negative x, and then negative 1 minus 3 gives me the negative 4. So I can combine the terms with the x's and the constant terms as well, and then that would be my final answer.
It's just that, 'cause I have a question.
Sure. What's up?
So why'd you have to? What's the point of changing the positive 3 to a negative 3 instead of just leaving it like that and just putting x minus 1 minus 2x plus 3?
Because you have to distribute the negative. You're subtracting the entire function from the other function. So you have to distribute that negative to each term in this function before you can combine anything. If you left it as minus 2x plus 3, that wouldn't be the correct answer, right? Because then we would get negative 1 plus 3. That gives me a positive 2 instead of the negative 4, which is the correct answer. So you have that negative sign. You have to distribute it to each term in the entire function there.
Okay.
All right. Good question, though. Any other questions? Okay. Let's take a look at example 6 here. Now I'm doing f times g of t. All right, so I'm taking two functions and multiplying them together. So I'll take the 4t plus 3, that entire function, and multiply that by 3t minus 1. That's what I'm going to have to write down to start here. So 4t plus 3 times 3t minus 1. When I'm multiplying two binomials together, so there's two-term factors there. What process do I have to go through to simplify this? What's that called? FOIL, right? Remember, FOIL stands for first, outer, inner, last. if I was multiplying, and we're going to see this in our review game, if I was multiplying 2 terms by a 3-term expression, I would distribute each term through and then combine like terms. Here, I just have to FOIL. So first term by first term, what's 4t times 3t? 12t squared. What's 4t times -1? -4t. What's 3 times 3t? 9t. And then 3 times -1? -3, right? So I FOIL. Then I go through and combine like terms. Well, what can I combine here to simplify this expression? Right, the -4t and the 9t. So I'll have 12t squared plus 5t minus 3. Okay. Any questions about that example? You're going to see a question very similar to your quiz on Friday. And on your review here in a second when we play the Kahoot and stuff. If you have a, like I said before, a binomial times maybe a trinomial, you have to distribute 1 term from the binomial, so this 2 term over here, to each term in the trinomial. Do it for the other term, then combine like terms. All right. Just so we're all aware of that process. Any questions about that? Okay. Flip over to the next page. And we're going to do examples 12 and 14 to kind of round out all of our operations here. In example 12, I am dividing those 2 functions together. All right. Our process for dividing. We first need to try and simplify our division problem as much as we can. Okay. So if I'm doing g of n divided by h of n, that would be 2n plus 1 over n squared plus 6n, right? Just writing 1 in the numerator, 1 in the denominator. But from here, I need to think about ways to maybe factor the numerator or take out a GCF, factor the denominator, take out a GCF, so I can maybe cross out some terms if I can and simplify this as much as possible. Okay? Everybody understand that idea? Well, is there any way for me to break down the numerator, the 2n plus 1 at all? What's that? Okay, so in the denominator, but just for right now, just for the numerator, is there anything that I can do to break down the numerator? Right. So there's really nothing that I can do. Okay. So I just leave that as is. But then, Jen, as you said, in the denominator, I'm going to look to maybe take out a GCF or factor that if I can. And what I can take out is an n, and what's left over inside my parentheses if I factor out the n plus 6. Break it down as much as you can. Notice that this doesn't necessarily help us cross anything out. Sometimes it will, sometimes it won't. But at least it's a little bit more simplified for us now to say, well, this is our final answer. And not only that, but one of the things that we had to do with our division problems with functions was find the restriction of the denominator. You remember talking about this? So anywhere where my denominator equals 0, I want to include that in my final answer as a restriction. Okay. In order to find the restrictions, I need to set the denominator equal to 0. Well, the reason it's easier to simplify and then do that process is because I'll take each term here, set it equal to 0, and solve. Well, right away, we see that there's a restriction, right? What can n not equal? 0. So n can't equal 0 because that's n by itself equal to this number. That's one of my restrictions. How would I solve the other equation? What's the other restriction? Subtract 6 from both sides, and I get n cannot equal -6. Good. So with the division problem, if you see this on Friday, you have to go through, simplify as much as you can, and then state restrictions for that division problem, right? So what values can n not equal in order for this to be the most simplified version of this division? Okay. Any questions about that example? So we've seen an addition, subtraction, multiplication, division problem. Now we have to look at that last kind of operation that we've dealt with, which is what's called the composition of functions, all right? And not only did we see this in this section, but we also saw it when we were talking about inverses, which is something we're going to review tomorrow. Composition of functions means you take the outer function, right? And wherever you see the variable for that function, you plug in the other one. Sometimes it will be written like this, so the f circle g of n. Other times, and like you'll see on the review game today and on the quiz, it'll kind of be written as f of g of n, something like this. So you know to plug in g of n wherever you see a variable in the f function. Do we remember talking about this a week or two ago when we first started chapter 6? Okay. So I start by writing down my outer function. So the 2n squared plus 5, right? That's my f function, my outer function. I'm going to start by writing that down. Now what I'm going to do is plug in n minus 5, the inner function, wherever I see an n. Be careful not to plug it in for n squared, right? We talked about that when we first went over these types of problems. You're plugging in n minus 5 for n, not n squared. So I have to square the n minus 5. What do I have to do first here to simplify? Think about your order of operations. Right, I have to do the n minus 5, and I have to square that, right? So how do I square n minus 5? What was that method we talked about earlier? Okay, all right. Yeah, sure, we can do that. So one thing that we remembered was I told you that little trick to just do it from this instead of having to expand it in FOIL. Square the first term. So you have n squared. 2 times the product of the middle term. So -5 times n is -5n times 2 is -10n. And then what's -5 squared? Or what's -5 times -5? 25. So that is a method for simplifying without actually having to write everything down in FOIL. Square the first term, get n squared. Multiply these two terms together, you get -5n, and then times that by 2 to get -10n, and then square the last term. -5 times -5 gives me +25. There any questions about that? If you were to expand it in FOIL, you'd get the same thing. You just have to worry about combining like terms and all that stuff. Okay. What do I have to do with this 2 on the outside? Distribute it through to each term. So I get 2n squared minus 10n plus 50 plus the 5 on the outside. So I have 2n squared minus 10n plus 55. And this is my answer for the composition of functions. So taking one function, plugging it into
Mr. Stackhouse,
the other function. Yes, question.
I think you forgot to multiply the 2 and the -10n.
You're absolutely right. So 2 times -10n is -20n. My apologies. But then we still had the 50 and the 55 on the outside. Thank you for that. Good catch. Any questions about that last example with the composition of functions or anything from the operations that we've seen today so far? Everybody good? Any questions at all? So hopefully that was a little bit of a review for us to kind of just go over each operation and what that looks like. I'll talk you through the process, and now it's time to kind of take this and be a little bit more independent. So what I'm going to do now is start a Kahoot. All right, it's 5 questions. It's similar to what we just did. So each problem or each operation is a different problem. Okay. We're going to go through and just practice each of these. Like I said at the beginning of class, kind of incentivize it a little bit. So if you end up on the podium or in the top 3, you get an extra point towards your grade for the quiz. So make sure that you work hard throughout this. Those of you that are home, you can still participate as well. This is the game code. All right, make sure that you put your name, because if you want extra credit and you put something crazy down, I won't know who it is, and then you won't get your points. So make sure that you join. Take a minute or 2 to let everybody get in, and then we will start. Okay. As you're joining, one thing that I'll say towards the end of class as well, everything that we didn't get done in the packet for today is due for homework. So it's about 8 to 10 problems, just kind of going through each different operation, hopefully solidifies everything from section 6.1 for us. All right. Other than that, what we're going to do throughout this Kahoot as well, if there's a problem that we all kind of just understand we do well, we'll move on from there. If there's a problem that we're kind of all over the board with our answers, I'm going to take some time to just make sure that we go over those also. Okay. So make sure that you're staying alert and kind of paying attention to what I'm saying. Might help you with, what we're going to be doing on Friday as well. All right. Also, each question has a different time limit based off of the type of question it is. So some might be 1.5 minutes, some might be 2 minutes, depends on what we're doing. All right. Anybody still need to join? Everybody good? Just lost somebody. Am I good to start this? Anybody at home still need to join? Okay. We're gonna get started then. So we have 17 total people. Make sure that you're writing the question down, following along on a separate sheet of paper. First question is addition. So you're taking those 2 functions and just adding them together. You have 1 minute to do so. What I would suggest doing for those of you that are here is maybe just using the back of the packet, so that way you have extra problems to kind of look at for tonight. About 10 seconds here. All right, good. So for the most part, everyone did pretty well. Take the x squared plus 4, add 2x minus 5. So I'm just looking to combine like terms. The only terms I can combine there are the constants. So the 4 minus the 5 gives me the -1. The x squared and the 2x stay the same. All right. Question 2, now we're doing subtraction. Remember what we talked about when we were going over this? And you have a minute and a half to do this, by the way. Make sure that you're distributing that negative to each term in the second function, right? Then combining like terms. Am I in the way of anyone's answers here? Sorry. They're all pretty similar, those answers. So make sure that you're paying attention to sign changes and stuff like that. Make sure you choose the correct answer. Ten seconds here. All right. So looks like the difference there between the C and D answers. Remember, you're distributing the negative sign in your second function. So it'd be 4x minus 2 minus x squared minus 5x. All right. So that's how we get the negative x squared in the beginning of our answer there. Okay. So be careful with the sign changes. This one, you are multiplying these two functions together. So x plus 1 times x squared plus x minus 3. You have 2 minutes to do this one. Look at the fact that you're multiplying a binomial times a trinomial. So you have to distribute each term through and then combine like terms. All right. Minute left. Thirty seconds. All right, really nice job. So, like we talked about, when we are multiplying through, we multiply the x times each term. So that gave us x cubed plus x squared minus 3x. Multiply through by 1 gives us pretty much that entire function back, and then you're combining like terms. So that's what gave us the final answer: x cubed plus 2x squared minus 2x minus 3. All right. Make sure that you're distributing each term through to the trinomial. You'll see a question very similar to this on the quiz on Friday, just as a heads up. All right. Okay, now we're going through and dividing. Now for this problem, I just want you to find the restrictions, okay? You still have to go through and divide and simplify to help you with this type of problem. So make sure that you do that first, then state what the restriction is. So you're just saying x can't equal this number, okay? So maybe you made a mistake then. So make sure that you divide through, simplify first, then state the restriction. "45 seconds here. "10 seconds. Okay. Definitely gonna go over this one. So the correct answer was B. So x can't equal 0. Let's take a look at why that's the case. All right. So the two functions that they give you, they say f of x is 2x plus 2, g of x is x squared plus x. All right. So if I'm going through and dividing these, I have 2x plus 2 in my numerator, x squared plus x in my denominator. What I told you guys to do is to make sure that you simplify before you state any restrictions. Well, take it numerator first, denominator second. I can take out a GCF in my numerator. In fact, I can take out a 2, which leaves me with x plus 1. I can do the same thing in my denominator. What can I take out of my denominator as GCF? X. And I'm left with x plus 1. Well, with these division problems, I can actually cross off the x plus 1s to simplify, and I'm left with 2 over x. That leaves me with the only possible restriction to be where my denominator equals 0. So x cannot equal 0 is my only restriction. All right. If you picked -1, that would be the closest other answer because you had the x plus 1 down there as well. So no fault to you there. However, make sure that you're simplifying before you do the restrictions, right? That's the whole division problem. Any questions about that? Okay. Last question. You're doing a composition of functions, so f of g of x. So wherever you see an x in the f function, you're plugging in g of x. minute left here. Thirty seconds. Ten seconds. All right, pretty good job here. So taking the function f of x, plugging in g wherever you see that. So just for those, since we still did miss this a little bit, I'm going to go over this. We have f of x is negative 3x plus 2. G of x is 2x plus 3. So negative 3x plus 2, I'm going to start with that. And then wherever I see an x, I'm plugging in 2x plus 3. Plus the 2 on the outside. Don't forget to include all of the addition or subtraction along with your problem here. You distribute the negative 3, that gives you the negative 6x minus 9 plus 2, and then I go through and combine like terms, which gives me negative 6x minus 7, which was my final answer. All right. Any questions about that or anything that we covered today? Period 3. Emily and Jenna, nice. No dudes on the podium so far today. That's all that about. Fourth. Close. All right. Maybe later today. All right. Your homework for tonight. So actually, give me a second here. I'll share my screen. Is to finish all the problems from the review packet that we did not do. So it's about 8 or 10 questions that we have not covered yet. So all the operations, when you come in tomorrow or online tomorrow, we'll go over those problems, and then we will continue with our review of section 6.2, which is all about inverses and things like that. Make sure that you access the review materials. So we're good to go for tomorrow. All right. Other than that, those of you that are home, you can go ahead and sign off, and I'll see you all then. All right.